everybody, so in this lesson we're going to be going over a little bit of vocab involving circles, and then we're going to look at central and inscribed angles of circles. So I do have a worksheet to go along with this lesson. If you haven't already printed it out, you might want to do that first. Okay, so in this first part we're going to go over some vocabulary terms. A lot of these you know already, we're just putting a formal definition to it. Okay, so a circle is defined as the set of all points in a plane that are equidistant from a fixed point called the center. Okay, so every circle has a center and it's always named by its center. So here we have circle A. Okay, so every single point on the circle is an equal distance from point A. Okay, the radius is the segment that's drawn from the center to any point on the circle, okay? So we know that in a circle, all radii are congruent, right? So whenever I go from the center to any point on the circle, all of those are radii, and all radii are congruent. All right, a chord is a segment that joins 2 points on a circle. And a diameter is a chord that contains the center of the circle. All right, it's also the longest chord. Okay? All right, next definition is a tangent line. All right, so a tangent line is a line in the plane of a circle that intersects the circle at only one point. Okay, so I gave you guys one picture. Here's another picture. So again, a tangent is only going to intersect a circle at one point. All right, a secant is a line that intersects a circle at 2 points. And then the last definition is an arc. Okay, so an arc is a part of a circle's circumference. All right, so we know that in a circle there's 360 degrees. So a major arc is an arc that's more than 180, and it's usually named by 3 letters. Okay, so it has to be more than half the circle to be greater than 180 degrees. So that would be like arc ACB, right? If I trace ACB, that's more than half the circle. All right, and the symbol for an arc looks like an arc. All right, a minor arc is an arc that's less than 180 degrees, and that's usually named, that should say 2 letters. Okay, so your minor arc would be like arc AB. All right, so that's the vocabulary. So now in the next part, we're going to talk about central angles and inscribed angles. So a central angle is an angle formed by 2 intersecting radii, and the vertex of the angle is always at the center. Right? So here we have an inscribed angle. The vertex is at the center, and it's formed by 2 radii. All right? A central angle is always equal to the measure of its intercepted arc. Okay, so if I take a highlighter and I trace this angle right here, this angle intercepts arc AB. So since a central angle is equal to its intercepted arc, we know that x is 80 degrees. All right, let's take a look at the next example. Okay, so this one says in circle O, the ratio of arc BA to AG to GF is 3:2:1. Okay, so BA is this arc right here. AG is the one next to it, and GF is the third one. So you notice those 3 arcs make up half the circle. Okay? So half a circle has 180 degrees. So I'm going to set up my equation as 3x plus 2x plus 1x equals 180. Okay, so if we combine like terms, we get 6x. And then if we divide, x is 30 degrees. Okay, so now I can go in and I can plug that in. So arc BA is represented by 3x. So 3 times 30 is going to be 90 degrees. Arc AG is represented by 2x. So 2 times 30 is going to be 60 degrees. And arc GF is represented by 1x, so that's 30 degrees. All right, and again, if I add those values up, I do get 180. So then it said find the measure of angle GOF. So GOF is a central angle, right? Its vertex is at the center, and it's formed by 2 radii. So it's equal to its intercepted arc. So the measure of angle GOF is 30 degrees. Okay, so a central angle is always equal to its intercepted arc. All right, next one is an inscribed angle. So an inscribed angle is an angle whose vertex is on the circle. Okay, so you'll notice here in this angle, B is the vertex, and it's actually on the circle. And it's formed by 2 intersecting chords. Okay, so the rule is an inscribed angle is half the measure of its intercepted arc. So here, x is going to be half of 100, which is 50. Okay, so if we look at the practice problems below, all right, again, inscribed angle, the vertex is on the circle, and it's formed by 2 chords. So in this first example, this inscribed angle is going to be half its intercepted arc. So here, x is 25 degrees. Okay, in this example, we don't actually know what the intercepted arc is, all right, but we can figure that out pretty easily. Okay, we know that there's 360 degrees in a circle. So if this arc is 160 and this arc is 100, we know that missing arc has to be 100 because all the arcs have to add up to 360. So here, x is going to be 50 degrees. Okay, last example, you got to be a little careful. They gave you the angle. So here they tell you this angle is 80 degrees, and this time they want the arc. So the arc is twice as much as the angle. So x, in this case, is going to be 160. Okay. Then we have an angle formed by a tangent and a chord. Okay, so in this example, AC is my tangent line because it's only touching the circle at one point. So there's my tangent, and here's a chord. Okay, so an angle formed by a tangent and a chord is half the measure of its intercepted arc. So this angle intercepts this arc right here. Okay, so again, since there's 360 degrees in a circle, we know that this yellow arc right here has to be 120 degrees, and then x is half of that, so that's going to be 60. Right, and then the last rule we want to go over, a radius or diameter is always perpendicular to a tangent line at the point of tangency. Okay, so remember, a diameter is a chord. So here we have a chord, and we have a tangent line. So again, it's intercepting half the circle. So we know half a circle is 180 degrees, so that's going to make x equal to 90. All right, and then the same rule is going to apply for a radius because a radius is just half of a diameter. Okay, so whenever a diameter is perpendicular to, a radius or diameter is always perpendicular to a tangent line at the point of tangency, so the point where they intersect. That's always going to be a 90-degree angle. All right, so I hope that this was helpful. All right, these are some of the rules that we're going over for circles. I did put up a practice worksheet so that you guys can try a couple of questions on your own. And then I'll also post the answer key so that you guys can check your work. Okay, hope this was helpful. If you have any questions, you can always shoot me a message on Google Classroom or email me.